Thank you for joining me in this presentation. I'm going to look at the third part of a SAC that we've recently completed. I will go across to, hopefully you can see this. Question 3, investigate different values of D, which will allow the wall to pass between the fence and the boundary of the tree. Now, a quick mud map, a quick diagram. Because there's the west building, there's the east building. Investigate different values which allow the wall to pass between the fence and the boundary of the tree. There's the fence, it's 4 meters below. That was 60-10. There was a tree here at 24.9, and it had a radius of 3. Now, there's the origin 0, 0. The wall must not touch the tree or the fence, so it's got to pass between the fence and the tree. Okay, so really we want, we just want it to pass in here. It has to pass in here. Okay. Sketch at least 3 possible solutions with their respective D. Okay, so now our formula here, D, went from this point to this point. And we can have different D values, but we want to find out what is our restrictions. What is our restriction? Now remember, where did D come from? D was the position 24D, wasn't it? From 0, 0, 60, 10, 24D. Well, D is the Y value for this point here when X is 24. So investigate different values of D. Well, state and give reasons for any values of D which will not be possible. All right, let's start there. What are some not possible values for D? Not possible values for D. Well, if it's going to pass between the fence and the tree, D has to be, cannot be 6. D cannot equal 6. Give reason. Why D cannot equal 6? Because this will cause the wall to touch the tree. And we can't have that, all right? What is another? Give any values of D which are not possible. All right, any values of D which are not possible. There is a value of D which is not possible. So you can state more to be safe. D cannot be -4. D cannot equal -4. Why? Because this will cause the wall to touch the fence. All right, there we go. That will do. We can name more. You could say D cannot be greater than 6. You could say D cannot be less than -4. All right, we've mentioned basically our boundary lines, and we haven't mentioned we can also D cannot be greater than 6 or less than -4 because the wall will not pass between the fence and the tree, which is our condition. All right, investigate different values of D. That's what we're doing. Now, you could use a graph to investigate this. However, we can see without a graph. You can look at this and see without plotting any values for D. You could graph it and you could test it, but this is not a difficult question because D happens to be the y coordinate of our point. All we have to do now is, which will allow, what are the values of D which will allow the wall to pass between the fence and the, so our values for D must be greater than -4 and less than 6 to pass between the fence and the wall. The fence and the tree, sorry. D is between -4 and 6. All right. So that keeps our restricted values not -4, not 6. All right. That's fine. And let's now just wondering, D is the set. That's fine. Sketch at least 3 possible solutions with their respective values on the same axis. All right, any 3 values. Okay, now just going to use 20, 30, 40, 50, 60, 70, 80, 10, 20, 10, 20. Forty, 60. It's a bit small. 60, 10. 0, 0. Our fence is at -4. Our tree okay. Now we can use our graphic calculator. If you get the graph and choose different D's, then you could possibly draw your parabola. However, we know that if, let's say, D was, say, 4, that's 24, 4. If D equals 4, it'll pass through the point 24, 4. And that may be, that may mean that it's not turning yet. It's going to pass through there. So we have to draw your parabola. I'm going to put a different value, say D is 3, because it will pass through 24, 0. Now, to pass through 24, 0, it has to come down and then up, because there's a level here. So I'll just do a different color that you can see. Green. Well, that didn't work. It's getting it better, but it has to pass through 20, 0. Now, let's try another value, say D equals, let's go down to, say, -3. It'll pass through 24, -3. And so it's going to cross probably about 48. So it's going to turn there and pass through there. Okay, so for your 3 curves, there's a mark for each one of these. There's a mark for stating possible values where D cannot equal. There's a mark for giving the interval where D is between -4 and less than 6. And there's a mark for your justification. So we're dealing with 6 marks in this question. I hope this has helped. Gives you an idea on what you need to be able to do. However, I just want to make one, if you're looking at this, just a side question while I got your attention. Tell me, if a gradient of a curve happens to be 2, what is the angle that it is? What is that angle? So if it goes up 2, cross 1, let's try and do it properly. If it goes cross 1, up 2, what is that angle? Do you remember that? Tan of theta equals over adjacent, rise over run, which is gradient, delta y over delta x. Tan of theta equals 2. Therefore, theta will be inverse tan of 2. Pick up the calculator and shift tan 2. It's about 63.4 degrees, approximately 63.4 degrees. Bit of geometry. Hopefully, information about graphing in these small help sessions has been useful. Until next time, stay happy. might stop the recording. Cheers.